Hello, everyone. Hope you are doing well. We are back again to another live session, right? We are going to look at the recap of all the videos that we went through, all the videos that was put out there from lesson 21 to lesson 30. So from lesson 21 to lesson 30, we have gone through looking at parabolic functions. So we've considered parabolic functions. So we saw that for parabolic functions, right? Parabolic functions, another name for rates is a quadratic function, right? Another name for rates is a quadratic function. And for quadratic function, right, we see that for quadratic functions, they refer basically to the type of functions that are of the form ax squared plus bx plus c is equal to 0. So a function that is of the form ax squared plus bx plus c, right, is equal to f of x in a way. If it's 0, then it's an equation. So it's equal to f of x is a parabolic function. When we write it as ax squared plus bx plus c is equal to 0, then it becomes an equation. Then it becomes an equation, right? Then it becomes an equation. So that is basically what a parabolic function is. That is what basically a parabolic function is. So we mentioned that for parabolic function, you can write it of the form ax squared plus bx plus c, which is equal to f of x, right? Now, another thing we looked at is the nature of the graph of parabolic function. So when we consider the nature of graph of parabolic function, we see that for the nature of graph, basically it is either curved like the intersection sign, like this, or curved like the union sign, like this. So it can look curved like the intersection sign or curved like the union sign. Can you remember how or when we say that a parabolic function or a quadratic function is curved like the intersection sign, and when a parabolic or a quadratic function is curved downward, right? We say that we determine that based on the coefficient of the s squared. So when we have the coefficient of the s squared, right, so ax squared plus bx plus c is equal to, let's say, f of x. If the coefficient of the x squared, which is the a, right, or ax squared plus bx plus c is equal to 0, if the coefficient of the x squared, which is the a, is less than 0, then we see that the graph of the function is like this, right? It's like this. So it's like the intersection sign, basically. Or the downward part is open, right? The downward part is open. Also, we say that negative numbers. So for instance, if we have negative 3x squared plus 2x plus 6, we should know that the graph of that function should look something like this, right? If we have negative x squared minus 6, we know that the graph of that function should look something like this, right? And then when we have a, right, to be greater than 0, or a being positive, then we see that the function or the graph of that function is curved downward. So it looks like this. It's curved downward. So for instance, for that graph, you realize that the graph of the function will be curved downward, right? So if we have a function, for instance, x squared minus 3x plus 1, so because the coefficient of the x squared is positive, then we see that basically it is curved downward like this. And then when the coefficient of the x squared, right, is positive, like 3x squared plus 2x plus 6, then we see that the coefficient of that is also curved downward, right? So that is the nature of the graph for these type of functions, right? For the parabolic functions, that is the nature of the graph. You realize that they are either curved downward or they are curved upward. So depending on the type of, right, A that we have, it can either be curved upward or downward. I hope this is very clear, right? So let's look at an example. So we can be asked to look at actually a curve, right? A quadratic function that is f of x is equal to x squared plus 5x minus 6, right? What is the nature of the graph of this, or how is it looking like? So we see that because it's positive, the quadratic function will be curved downward, right? We could also look at the fact that for the quadratic function, if we want to look at the nature of the roots, right, of a quadratic equation, we want to look at whether the roots are real roots or the roots are, right, not real, or probably they are repeated roots, although they are the complex type of roots. Then we must consider the b squared minus 4ac, right, in the quadratic equation, right? So when we take a quadratic equation that is of the form as squared plus bs plus c, right, the b squared minus 4ac determines the nature, right? So when the equation has real roots, right, real roots, then it means that b squared minus 4ac will be greater than or equal to 0, right? Probably specifically when b squared minus 4ac is greater than 0, then it has real distinct roots, right? It means that its roots are real and also distinct, right? So it means that probably one root can be, let's say, x minus a, and another one can be x minus b, where we have x to be equal to a and x to be equal to b. So it is real and it is distinct, it's different, right? That is when it's greater than 0. When b squared minus 4ac is equal to 0, then it is real, right, and repeated. It's real and repeated. So for instance, it can be x minus a and another x minus a. So we'll look at a question right now, and then I'll give you one to try and put it in the comment section, right? So for instance, if I have a quadratic equation x squared minus 5x plus 6, right, is equal to 0, you can be asked to determine the nature, right, of the quadratic equation. You want to determine the nature of the quadratic equation. So one thing we must look at is that first we must compare this quadratic equation with the general form of the equation, which is as squared plus bs plus c is equal to 0, right? We are comparing it with the general form of the equation, which is as squared plus bs plus c, which is equal to 0. Then once we've been able to do that, what we need to do is that we now want to actually compare, right? So the coefficient of a in this is 1, right? That is the coefficient of a in this, right? And then we know that the coefficient of b in this is negative 5, right? And then we also know that the constant term, right, which is c, is equal to 6. I hope it's clear. So the constant term, which is c, is equal to 6. So once we are able to get a, b, and c, all that we are going to do now is that we are going to take right, discriminant, or we know that is what we call b squared minus 4ac, right? And then we'll look at the value. Once it is greater than 0, then we can say that that is actually a real and distinct root, right? Once it is probably equal to 0, then they are equal roots, right? We don't look at when it's less than 0. When it's less than 0, it means that those roots are complex, right? They are not real, right? They are not real roots, right? So once you are watching, you can be liking the live so that it goes farther and then other people are able to join, right? So continue to like it, right? So it means that once we have our A to be 1, our B is -5, our C is 6, we put it into this, right? So it means that we're going to have -5 all squared. That's the B. B is -5. So -5 all squared -4. Our A is 1, and then our C is 6, right? So let's see the value that we get. So -5 all squared gives us 25, right? Minus, this gives us 4, and then times 6. 4, 6, 24. So 25 minus 24 gives us 1, right? So we ask ourselves, is 1 greater than 0, less than 0, or equal to 0? So 1 is greater than 0. So what will be the conclusion on this? We can conclude that, right, since 1 is greater than 0, then the quadratic equation has which type of roots based on what we just learned? The quadratic equation has what? We said when it's greater than 0, it has what? Real roots and distinct roots. So the quadratic equation, we can say, has real and distinct what? Roots. The quadratic equation, right, has real and distinct roots. I hope it's clear. So that is how we are able to determine the nature or roots of a quadratic equation. So once we see that the value is greater than 0, then it will be real and distinct roots. Once the value is equal to 0, then we will see that it has probably what we call the repeated roots, obviously. And then once we see that it is less than 0, then we say that, so when we say b squared minus 4ac, once it's less than 0, then it has complex roots, right? It has complex roots. It means that once you realize that the value there, right, the value here, right, is a value that is in the negative, right, it's less than 0, it's negative, then it means that that root is complex, right? We can't find any real root for it because that is what's in a square root. And we know that square root of a negative number, right, it's not real, it's complex. It will end up giving you an I, right? So let me give another example, right? You take your time and go through it and then determine it. So determine, the question says determine the nature of the roots of the quadratic equation s squared, right, plus x plus 12 is equal to 0. S squared plus x plus 12 is equal to 0. So I'll give you about 2 minutes. Go through the process and determine the nature and write your solution in the comment section, right? Write your solution in the comment section. Let's see the nature of the quadratic equation, right? When we consider the b squared minus 4ac. Once you get your answer, put your solution in the comment section, right? And then let's see whether, right, put your solution in the comment section. We want to determine the nature of the quadratic equation, right? So I hope you are working it. Okay. So, okay. So, Nathaniel, you are saying that -47 and it's less than 0. So it means that it's complex. Very good. Very, very good. That's excellent. Very, very nice. Good to know you've been able to catch this. Oh, okay. Prince Power is also saying that it's a complex truth. That's very nice. That's very good. I'm impressed. I'm impressed. So it means that b squared minus 4ac, right? So we know that our a is a coefficient of x squared, which is 1, right? Our b, which is a coefficient of x, which is also 1. And then our c is 12. So substituting it in here, we'll get what? 1 all square minus 4 multiplying 1 multiplying 12. And we know that that gives us 1 minus 48, which is negative 47. So we see negative 47 is less than 0, right? So once it is less than 0, we know that the nature of the root is a complex root. And that's nice. It's nice that you've been able to get it. The nature of the root is a complex root. Now let's look at one last example. I'll give you another one example to try. So it says that determine the nature, right, of the quadratic equation, right? And we have our quadratic equation to be, right? So we have our quadratic equation. Let me pick one quadratic equation that would be repeated, right? So we want a quadratic equation that would have repeated roots, right? So let's use this example. So our quadratic equation will be 2x squared minus x plus 5, right? Is equal to 0. So try this as I, and then try this as well. X squared minus 2x plus 1 is equal to 0. So try and go through it in the next 2 minutes. Determine the nature of these two, and then write your solution in the comment section, right? Once you're writing the solution, continue to like the live so that we can continue to get more people joining. You can get to a lot of people. So solve this. Determine the nature of the quadratic equations here, right? So we'll not solve this. I want you to solve yourself. When you write it out, write it here. When you tell me the nature, write it here. So what is the nature of the quadratic equation for I? And what is the nature of the quadratic equation for II? Right, so let's look at the nature of the quadratic equation for I. Okay, so Nathaniel says I is a complex, right, root. So it's complex root. You also agree? The others on live, Collins, Prince, Calvin, do you also agree that the nature of the quadratic equation we have here is a complex root? And then how about the II? Try and go through the II as well. What is the nature of the quadratic equation for II? Right, what is the nature of the quadratic equation for II? Okay, so Calvin says it's a complex root, so that is it. Now let's look at the II as well. What's the nature of the quadratic equation for II? Right. So let's go through the nature of the quadratic equation for II. Very good. So Prince says that II is a repeated root. Okay. II is a repeated root. Very nice. Very good. Okay, so it is real and repeated. Very good. So it's a real and a repeated root. So that is II, a real and repeated root. That is very good. You've done so well. I'm impressed with the progress. So now I want us to look at a question. So let's consider this question, right? So we are going to look at a real life situation of how we can actually apply the parabolic functions in real life. So this question is a very interesting question. You can screenshot it, you can probably write it down so that both of us will go through along with it and then be able to look at how we can solve this. So let's consider the question, right? Let's consider the question. So the question says that, right, James is practicing free throws. So we see how real and how practical the quadratic equation is to our real life. So playing basketball, right? James is literally practicing free throws. And then the path of the basketball can be modeled by the quadratic function, right? So we are going to model that free throws that he's practicing, the basketball, right? Using the function. And we know that once it's a basketball, the ball will move in the form of a curve, right? So basically we are going to get what? A quadratic function. So the quadratic function is height with respect to t, right? H of t, right? So it's modeled on time. So minus 5t squared plus 10t plus 1.8, right? So that is the function. H of t is equal to minus 5t squared plus 10t, right? Plus 1.8. Now, where we have our h, right, to be the height of the ball above ground level, and our t to be the time the ball, right, since the ball was in seconds, right? So the t represents the time, and then our h represents the height of the ball. Very good. So we have to plot a graph for the function using an appropriate scale as this 4 time n height. So that is the first part of the question. And then the second part of the question, we want to look at the height of the ball. At what height of the ball, the moment, right? Okay, what is the height of the ball the moment it left Jamie's hand at t is equal to 0? So what is the height of the ball the moment it left Jamie's hand at t is equal to 0? Right, which is a very practical and simple question. And then what was the maximum height reached by the ball? Right, so at what time did this occur? So we want to look at the maximum height that it reached, right, and at what time it occurred. So let's consider how we can actually use right, graph to be able to go through this. So first and foremost, we should be able to write out the equation or the modeled equation. So we know that the modeled equation basically is h of t, right? The modeled equation is h of t, which is equal to minus 5t squared plus 10t plus 1.8. I can't see where you are, but I'm hoping that you would also probably take a jotter and sketch the graph of this function, right? So let me move to my grid, right? So I want to use a grid here so that, or my graph, so that I can be able to get my graph of the function, right? So we know that before we can draw the graph of the function, we need to pick some values. But then remember that the height and the time cannot be negative, right? So it means that we can have a t, right? And then we'll have our h of t here. So we have a t, and a t will be in terms of time, and then it should be positive. So we can pick from, let's say, 0 seconds to 1 second to 2 seconds to 3 seconds. We can even pick 0.5 seconds so that it looks better. Let's use 0.5, right? So we are going to have, right, our t, and then we'll have our h of t, right? It's not always x and y, right? So we'll begin from, let's say, 0, and then we can have 0.5, then we can have 1, we can have 1.5, we can have 2, we can have 2.5, and then 3, we can have 3.5, then we can have 4. You know, for practicality, when you throw a ball and it's going into the basket, it doesn't take more than probably 2 or 3 seconds for it to be able to reach the basket. and then probably reach the floor, right? So with this, they didn't give us any, right, interval. So we are using realistic intervals for our t. Now we want to find our h of t. So as we've looked at in most of the lessons when we are finding parabolic function, all we need to do is that we need to take h of t. So we want to find h of 0 for the first one, which implies that minus 5, 0 all squared, right, plus 10 multiplying 0 plus 1.8. So it means that h of 0 will give us what? 1.8, right? So it means this is 1.8, right, which is a positive 1. And then we can actually go through the rest using the calculator. So we are going to have minus 5 multiplying 0.5, right, all squared, right, plus 10 multiplying 0.5, right, and then plus 1.8. So we see that that gives us 5.55. So we have 5.55. And then when we use 1, right, when we use 1, we are going to have 1 here, right? Then we will also have 1 here, right? And in that case, we are going to have negative 5 multiplying 1 all squared plus 10 multiplying 1, right, plus 1.8 multiplying 1. And that will give us 6.8. So I believe you are also filling it at home. So the next one, using the calculator, you are going to use 1.5, right? And then we are going to use 1.5, right? And then we are going to have 1.8 multiplying 1.5. And in that case, you are going to have, right, our value to be equal to, right, so negative 5 multiplying 1.5 all squared plus 10 multiplying 1.5, right, plus 1.8 multiplying 1.5. So that gives us 5.55, right? So this gives us 5.55 as well. And then we have our 2, right? So when we use 2 in place of the x, or the t, in this case is t, right? So negative 5 multiplying 2 all squared plus 10 multiplying 2, right, plus 10 multiplying 2, right, and then plus 1.8 multiplying 2, 1.8 multiplying 2, that gives us 3.6. I have to go through this again. Probably I might have left something somewhere. So we are going to go to 2.5. So we are going to use 2.5 here, right? All squared plus 10 multiplying 2.5, right? 2.5 plus 1.8 multiplying 2.5, right? So in this case, 2.5. So that will also give us, right, negative 1.75. So in this case, we have negative 1.75. Now that we are going into negative height, and we can even probably leave it here, right? We will not want to go into the negative because we know that we are dealing with basketball, so we will not go to negative, right? So let's go through this again. The first one is 0, and the h of t is 1.8, right? The next one is 0.5. So we have 0.5 in place of the t, right? And once we do that using the calculator, we should get our h of t, right? Need to be very sure of what we are getting to be 4.65, right? So it means that the second one, I probably didn't punch in the value well. So our second one should give us 4.65. 4.65. I hope you agree with me. You are doing it as well, and then you agree that that should be 4.65. Now let's check the next one, right? So our second one should be 4.65, right? And then the 1.5 is 21.75. Really? The 0.5 is 5.5. Okay, so negative 5 multiplying 0.5 all squared, right? Plus 10 multiplying 0.5, right? And then plus 1.8 multiplying 0.5. So that gives us 4.65. Okay, so that should give us 4.65. So 2.5 is 11.75. Oh, okay. Check the 2.5 wall. Should it be 11.65? So you have 2.5 all squared plus 10 multiplying 2.5, right? And then plus 1.8 multiplying 2.5. So that should give us negative 7 over 4, which is negative 1.74, right? When it is 2, right, need to go through it one by one. When it is 2, it means that when we substitute 2 into the t, right, we are going to have negative 5 multiplying 2 all squared plus 10 multiplying 2, right, plus 1.8, right, which gives us, oh, okay, so what I do is that I multiply the 1.8 by the t again, and that would give me very, very wrong variable. So let's go through this again, right? So 1.8 must be okay. So let's go through it again. So the first one is 1.8. Let me clean this so that we go through the other ones, right? I probably writing it should make it easier or should make it better, right? So when h is 0.5, then it means that I'm going to have negative 5 multiplying 0.5 all squared plus 10 multiplying 0.5 plus 1.8, right? What does that give us? So you multiply 0.5, right, all squared plus 10 multiplying 0.5, right? 10 multiplying 0.5, 0.5, and then plus 18, right? So we don't put anything, we don't multiply the plus 1.8 by anything. Oh, so it should be 5.55. So what I did earlier was right. 5.55. Okay, that's fine. So one is 1.68, right? Or 6.8 in a way. So one is 6.8. And then 1.5 is 21.75. And then 2, right? So let's check for 1, right? So negative 5 multiplying 1, right? All squared plus 10 multiplying 1. Okay. Then plus 1.8, which gives us 6.8. So that is right. And then we look at 1.5. So 1.5, right? And then 1.5. So that gives us 5.55. So 1.5 gives us 1.55, not 21.75. So this is 5.55. Now how about 2? So when we substitute 2 in, right, we are going to have 2, right? And then we are going to have our 2 here. And that is going to give us, right, 9 over 5. So 9 over 5 is going to be 9 divided by 5 will be 9 divided by 5, right? 1.8, that's good, 1.8. Right, now let's check for 2.5. So 2.5, what would that give us for 2.5? It means they are going to have negative 5 multiplying 2.5 all squared, right? And then we have plus 10 multiplying 2.5, right? Plus minus 1.8, right? Or plus 1.8, so plus 1.8. So that gives us what? 4.45. Negative 4.45, not 4.45. It should be negative, right? So it's in a negative, so negative 4.45. So as I said, because we get to the negative, I need to end here. Now let's draw our graph, right? So we see that for our graph, we have more positive values. So we are going to basically make it a graph of more positive values, right? Okay. Then just the last part, we have our height, our h of t being negative 4.45. Okay, so you are going to plot the ordered pair of points, but then before then, let's use intervals, right? So you are going to have 0.5, then we can have 1, we can have 1.5, right? We can have 2, we can have 2.5, right? We can have 3, but it ends at 2.5 anyway. Then we got 3.5. So this represents our t, right? Let this side represents our h of t, the height of the basketball. So in this case, it begins from 1.8 and then it goes down to negative 4.45. So let's actually use 1, right? So 1, we can have 2, we can have 3, right? We can have 4, right? We can have 5, we can have 6, we can have 7. Because I think the highest value here is 6.8. And at the negative side, we can have negative 1, right? Let me reduce this so that I can actually be able to look at the negative side, right? So we can have negative 2 here, right? We can move down and have negative 3 here, right? So negative 3, negative 4, right? And then let's reduce this further, right? So we can have negative 5 here. Let me use the ruler so that it looks well. Okay. Trying to draw a line through this side. Okay, so we can have negative 5 here. Right, so let's plot our points. So the first point is 0 and then 1.8. So we are going to have 0 and then 1.8, which is somewhere here. 0 on the t, 1.8 on the h of t. The next one is 0.5 and then 5.55, which is somewhere here. Right, 5.55 is here. And then the next one, we have 1, and then we have 6.8. So, okay, 1, and then we have 6.8. So somewhere here. Right, so you can as well do yours on the jotter. And then we have our 1.5, right, which goes to 5.5. So it means it's coming down. 5.55, which is here as well. Then we have 2, right, coming down to 1.8, which is here. Very good. 2 coming down to 1.8 here. And then 2.5 goes down here, right, to 4.45. So that is negative 4.45. That is somewhere here, right, which is not possible when it comes to the basket. The ground level would have actually gone. So we would use our line to pass through the point. Oh, this line has curved. It didn't pass through the point. Let me clean and put it there, right? So I think I want to use red for the curve. So we'll put the line through. Good. So we ignore this part of it, right? So we see that for the basketball, because we are dealing with basketball, the graph actually moves from this side, and then when it reaches this side, we know this is the maximum height. The maximum height, right? So this represents the maximum height. Obviously, so this represents the maximum height. So this is the graph of the quadratic equation that was given. Obviously, right? So it's a curve. And because the coefficient of the t-square is negative, as we see here, because the coefficient of the t-square is negative, we mentioned that it is normally curved, right, like the intersection. So we see it clearly over here. because it's -5 here, it's curved like the intersection as we see here. I hope it's clear. So that indication is seen very clearly. We see that it's curved like the intersection. Now, I'll let you go through solving the I part of the question. So let me read the I and then determine that for me. So the second part of the question, which is I. Now we've drawn the graph of the function. Now the I says that at what is the height, right? So let me write it here. I. What is the height, right, of the ball, the moment, right, the moment it left Jamie's hand, right, Jamie's hand at t is equal to 0. So please write in the comment section what will be the height, right, the moment it's left Jamie's hands at t is equal to 0. And how do we do that, or how do we find that? What is that height? So this is a practical question. It's practical. You need to be able to solve it practically, or to be able to determine that practically. So write the height for me. If you have any idea, write the height for me. What is the height? I'm waiting for responses, right? What is the height? Okay. I want to read some responses for the II. So we want to read and interpret. So at t is equal to 0, what is the height? We can see it clearly. We've done it, and we can see it clearly in the table. We can see it in the graph. It's showing everywhere. We can also as well probably do the substitution to see it. So what is the height? Very good. So I've gotten one response. I want more response. Who again is telling me the height? What is the height? Very good. Okay, so Nathaniel says 1.8. Calvin says 1.8. Prince says 1.8. Very good. So with this, they didn't give us any units. So bravo, you've done well. You've been able to determine the height. So the height is what we did here, right? So at t is equal to 0, right? We have h of 0 will be equal to -5 multiplying 0 plus 10 multiplying 0 plus 1.8, right? And which gives us 1.8 as the height. So the height is 1.8. And we can also see it here, right? The first point, that is when he threw the ball, right? So that is the height. And then now let's look at the I part of the question. You should be able to try and do this one as well for me. So I. Okay, let me write it here. So I. It says that what is the maximum height, right? What is the maximum height? Maximum height, right? What is the maximum height reached by the ball, right? What is the maximum height reached by the ball? And at what time? And at what time did the ball reach that height, right? Did the ball reach that height? So we want to look at the maximum height reached by the ball, and then the time, right, that ball reached the height. So write your answer in the comment section. Let's see whether you'd get this as well. Okay, so the maximum height is 6.8. Very good. And the time that it reached was in 1 second. That is very, very good. So we know that, when we look at the quadratic equation, minus b, right, plus or minus square root of b squared minus 4ac all over 2a, right? Taking just this part of the equation, right, determines the maximum height. So minus b all over 2a. You know that, right? So in some situations where you are not now having to go to do the graphical part, then you see where the maximum height is, right, which is a 6.8, and then the time, right, which is at 1 second. right, we can use this, right? When we take the quadratic equation, we can use minus b all over 2a to be able to determine that. So very good. The maximum height, as has been alluded by all of you, right, is equal to 6.8. And then the time that this maximum height, right, reaches that maximum height is at time 1 second, right? It's at time t, which is equal to 1 second. So if all done well, this is the practicality of the parabolic functions that we have looked at. So today in our life, we have gone through looking at the parabolic function, and we've probably taken our time to be able to look in depth into how we can probably look at the parabolic function in real life. I'll leave space for you to ask me some questions. If you have one question or two questions, you can ask, and then I'll tell you what is about to happen next week or what we are going to look at next week so that you can prepare and watch the videos. So this is just a recap of the things we looked at. We've probably not been able to recap on the inequality, but I believe that one you're okay with this, right? Okay, so someone is asking a very important question. It says that is a gradient m is equal to 0.133. So how do you determine the gradient of a curve? Right? How do you determine the gradient of a curve? And is it even possible to determine the gradient of a curve? That is a question you need to ask yourself, Nathaniel. So we know the gradient of a graph is the slope of the graph, right? The gradient of a graph is the slope of the graph. So once we are looking at the gradient of the curve, then we are probably going to consider the whole curve, right? And at each point, there is something that it is doing, right? So it's very difficult for us to know the actual slope, right? So it does something here, it does something here. But we can find the area around the curve. We can find the area around the curve, right? We can find the area around the curve. Yes, and to find the area around the curve, we will have to go to Isaac Newton and look at his calculus, right? So you realize that we have shapes that are known, right? So like rectangles, like squares, whose area we can find easily. In this case, length times breadth, length times length. But then when it comes to things like curve, we need to find the area of all the parts here. So for instance, we want to find the area of the shaded parts here, all these parts here. And in so doing, once we can integrate the curve, right, and integrate it on the bounce, we can be able to know the area here. So we'll consider the introduction to calculus as part of the things you are supposed to look at. So we will look at it from 0 here up to probably the highest level here, right? Or probably of t, right? So from 0 here to the point here, which is probably 2 points, maybe 2.1, right? So we want to find the integral of the function negative 5t squared plus 10t plus 1.8, right? The integral dt. So there's something else that we'll be looking at, right? And that is where we engage in what we call integration. Integration finds the area around the curve, right? So it's not that difficult at all. So with integration, all you are going to do is that you are going to actually add 1 to the squared here and divide it by the total number. We'll look at it. So we just move the constant outside and then we add 1. And we are going to have minus 5t cubed all over 3, right? In this case, plus 10t squared all over 2, right? And then plus 1.8t. So it's something that we will do. It won't be difficult at all, right? So that is the area around the curve. It's good that you know, because it helps you. Now you have actually been able to practicalize what we are doing and even moved it into calculus, which is integration, right? So next week we'll be looking at what we call the polynomial function. We'll look at operations on polynomial functions. We'll consider how we can divide polynomial functions. And then we'll also consider the method of completing the square when solving quadratic functions. And then we'll look at rational functions. And then we'll look at the composition of rational functions, which is partial fractions. So all these videos will be available for you next week during the course of the week. Make sure that you watch it. Make sure you share it with your friends, and then ensure that you are following all the time. We'll have our next live next week, Saturday, right? Have a nice day, right? So the calculus will not be difficult at all, right? It won't be difficult at all, right? So have a nice day, right? And you're going to enjoy calculus. Calculus is just one of the most meaningful mathematics that you are going to look at. So have a nice day, and then continue to learn. Next week, I'll not probably be able to have some of you because you'll be going to the boarding house. If you have a library and you have internet, you can join from your library, right? You can join from your library. We will still have the live, so you can join from your library. Because you'll be going on Friday, make sure you watch all the videos on time. Watch them on time before you go, right? And then see you. Have a nice day, and thank you so much for joining. You've done a wonderful job. Thank you so much.